Hello everyone, it's Daniel from TechMind Factory and welcome to this next video from the series called Identity Sphere Explorer. In this video, I would like to talk about identity management in AI agents. In the era of AI solutions and AI applications, identity management is a very important aspect. And the thing is that very often, most of those applications or AI solutions will have access to some confidential data. And the thing is that in such situations, we need to have strong authentication and authorization mechanisms in place. And that's why in this video, I would like to talk about some of the concepts related to authentication and authorization when building AI agents. In this specific video, I will use Semantic Kernel SDK from Microsoft to implement AI agent. I will use Auth0 to implement identity management for users and OpenFGA to implement granular authorization. So let's start. As always, let's start with a little bit of theory before we jump into practical examples. And obviously, this video is about implementing authentication and authorization in context of AI agents or AI applications, but I think that it's important to set the context and talk a little bit more about generative AI. So let's talk about generative AI or Gen AI first. So generative AI is a type of artificial intelligence that can create new content such as text, images, music, or even videos. It works by learning patterns and structures from large amounts of data and then using that knowledge to produce original outputs. So, as we can see, this generative AI is trained, okay? So it's learning patterns and structures from large amounts of data and then using this knowledge to produce original outputs. It works by recognizing patterns in the data it has studied and then using those patterns to generate something new and creative. It's like teaching a machine to mimic human creativity. And ChatGPT is a perfect example of generative AI. I'm pretty sure that most of the people that will watch this video, they have some experience with ChatGPT. They tried it. And generative AI uses machine learning or ML and large language models or LLM as core technologies to generate content such as text, images, or video. So the thing is, when you open ChatGPT and you will type your query like, hey, can you recommend some of the books about, I don't know, like cars, let's say, ChatGPT will respond and provide some hints what to read, for instance. But also you can ask ChatGPT, hey, can you draw the graphic that presents AI agent and user interaction, let's say, and then it will generate the image. So as you can see, sky is the limit and it's very impressive. Okay, so when talking about generative AI, I think that it's also very important to differentiate between two things. So AI systems and AI-powered applications. So AI systems are solutions that provide artificial intelligence capabilities. So this category includes systems such as GPT from OpenAI or Gemini from Google. Okay, so those are those systems, those large language models that you can use to ask different questions, and those systems will provide you some of those answers. And obviously, you know, like those systems are trained using a huge amount of data. However, thing is that those systems do not have access to your private data, like to access to your corporate data that you use inside your company. So that's why on the other side, we have those AI-powered applications. So those applications leveraging AI systems to provide advanced functionalities to users, like answering users' questions. And these are also called AI agents. So with AI-powered applications, we can leverage AI systems And also we can leverage the data that we own actually. And we can build our applications for end users. And those AI applications can be used in the enterprise. So for instance, we can provide our employees with the application that can, search for different kinds of documents used in the enterprise, in the company. But also it can be publicly available application, which can be used, to, for instance, find some songs or add them to favorites and so on and so forth. So sky is the limit, really. But the thing is that AI-powered applications are leveraging AI systems. And those large language models like GPT from OpenAI or Gemini from Google. And now, when we implement those AI-powered applications, there are different techniques that can be used here, but the most popular technique to implement AI agents to work with our data that we own actually is Retrieval Augmented Generation, or RAG. This is also like architecture pattern that is used to enrich the queries that are sent to large language models. Because as I mentioned before, when we talk to those LLMs, to those AI systems, obviously those systems can respond with some generic data or publicly available data, but those systems do not have any access or knowledge about our private data that we own actually. So when we talk about Retrieval Augmented Generation, or RAG, there are actually two steps to make it simple. Retrieval, so finding relevant information from a big collection of documents or knowledge sources like library or database or some file storage. And generation, so using an AI model like GPT to generate responses, explanations, or summaries using provided information from the retrieval process. So now let's look at this diagram. Here I will use Azure Cloud Services, but obviously Retrieval Augmented Generation or RAG architecture can be implemented with many different kinds of solutions outside of Azure Cloud. So there is application, and obviously this application is deployed on some server. And important thing is that this application is actually connected to AI system. So in this specific scenario, we are going to use Azure OpenAI and Azure AI Search. So let's start with Azure AI Search. It's a powerful solution that enables you to index data from different kinds of sources, structured and unstructured. So it can retrieve data from relational databases like SQL database. It can get information from Cosmos DB. It can retrieve information from PDF files or Excel spreadsheets stored in the storage account. And then this data can be indexed into Azure AI Search. So we can ask or send queries to Azure AI Search to retrieve information that is contained in those data sources like files, databases, and so on and so forth. It's really powerful. And now, once we retrieve this information, we can send user query or prompt along with this information retrieved using Azure AI Search. We can send it to this AI system or to the model, to GPT model, for instance. And with Azure OpenAI, we can create different kinds of models like ChatGPT or GPT, okay? And the thing is that those models are deployed in the Azure cloud, and then we can ask those models to give us a specific information. So in this specific scenario, as you can see, we are sending the prompt or the query from the user plus the knowledge that we retrieved from Azure AI Search, and then we get response from the specific model. And this is how Retrieval Augmented Generation approach or architecture works. So the thing is, just to summarize, that if we will ask ChatGPT, hey, can you provide me with the invoices that we sent to XYZ company last month? ChatGPT doesn't have such knowledge because it doesn't have access to your confidential data that you use in your enterprise. However, if you first ask Azure AI Search, like, hey, search for let's say XYZ company and invoices and so on and so forth, then Azure AI Search will retrieve all the data from different kinds of data sources that were indexed, and then it will attach this information to the query that you are sending to Azure OpenAI service, to the model. And then we can ask, hey, can you provide me with the information about invoices sent to XYZ company last month? And then we also attach the data from different kinds of data sources retrieved with Azure AI Search. And then this model that is used with Azure OpenAI can look into this data and can return relevant information for us. So that's very important to understand. So that's why we can get information about the data that is stored confidentially, let's say, in our enterprise. Okay, so now let's talk about identity challenges in the era of AI agents. So, believe me or not, but there are many threats behind building AI applications. So, we can see the report from OWASP Top 10 for LLM applications. So, it's called 2025 Top 10 Risk and Mitigations for LLM and Generative AI Applications. And obviously, you can access this report, it's publicly available. But in this specific video, I want to talk about a specific risk related to identity management. So, unintentional data exposure. A user receives a response containing another user's personal data due to inadequate data sanitization. Okay? So, it means that without proper authentication and authorization in place, users can retrieve information that actually they should not have access to. So, what is the risk? I want to talk about two of them. For me, in my opinion, biggest ones. Information disclosure, so unauthorized access to sensitive data through the exploitation of the application's features, and escalated privileges, so unauthorized elevated access, enabling unauthorized users to perform actions beyond their standard permissions. Okay? So when we look at those risks here, we naturally feel that it's about identity management. It's about authentication, so confirming who the user is, and authorization, so which information user is authorized to access. So let's talk about this scenario in practice. And for me, it's very important to show you this risk here. So that's why I created this diagram to discuss this risk, this threat when building AI agents. And obviously here, I will use some of the Azure Cloud services, but this diagram that I will show you right now, it discusses the concepts that can be used with any actually solutions or components, because it's more about the concepts. So there is a user and there is AI agent, okay? And now user is sending a query. So we are sending the prompt with the user query to AI agent. And now this AI agent, as you remember, we talk about retrieval augmented generation, or RAG, before sending this information to the model, this AI agent is searching for the information. And for this, Azure AI Search is used with the index data from different kinds of sources. So files from blob storage account are indexed there, like PDF files, Excel spreadsheets, but there is also some information from the SQL database retrieved here and stored in the Azure AI Search index. So now AI agent is sending this query to Azure AI Search. So obviously underneath we are using SDK for that. But as I mentioned, this information can be retrieved from different kinds of sources outside of the Azure Cloud scope. And now, once this information is retrieved, AI agent or AI application is submitting user prompt along with retrieved data to the model. For that, we use Azure OpenAI, and in the practical demo, we will see Azure OpenAI usage, but it can be any model, again, outside of Azure Cloud. It's more about the approach. So AI agent or AI application is submitting user prompt along with retrieved data. And now the model, like GPT, can look into this data, can look into its own trained information, and it can return information to the user. However, the thing is that when we are sending this information to the model, it has access to the whole knowledge base. So before returning the information to the user, there should be authorization check in place. Okay? So obviously, we will search for different kinds of documents using Azure AI Search. We will ask the model to actually provide us with the response basing on our query we sent. But before sending this information to the end user, AI agent should use authorization and do authorization check before returning the whole data to the user. So AI agent will provide information to the user, but this information will include only the information that user is allowed to access. And that's very important, okay? So here, this data is actually the data that user can access. So it's very important because in many of those applications, we are very excited about, what can be retrieved, how easily we can integrate with services like OpenAI. We can easily index data, retrieve information. But I would say the bigger challenge is to make sure that we will filter out this data and only authorized users will gain access to this information retrieved by the model actually. So this is the challenge here, which I want to talk about in this video. So implementing proper authentication for users and then proper authorization. Because without knowing who the user is, which is about the authentication, we will not be able to also implement proper authorization in place. So to check to which data user should have access to. Okay, so let's talk about best practices for access management in AI applications. So in this specific scenario, I strongly believe that developers should assume that users can exploit accessible data or functionality via crafted prompts, so those queries sent to AI agents, including fine-tuning data used for retrieval augmented generation, or API calls. So it's crucial to manage permissions and access controls carefully, allowing only authorized actions. So again, we don't want to provide all the data and return all the data to the user after user sent the query, the prompt. We want to filter out this data and we want to implement proper authorization check. And also, sensitive data access and privilege operations should occur under user's identity to stay within their authorization scope. So we talk about the authentication here. So leveraging existing authentication and authorization ensures secure access and minimizes the attack surface. So that's why in this video, we are going to talk about implementing authentication in AI agents using Auth0 and implementing authorization with OpenFGA and Okta FGA to implement granular authorization for our AI solutions. Before that, let's talk about AI agents with Semantic Kernel. So, what is Semantic Kernel actually? So Semantic Kernel is an open source SDK from Microsoft that empowers developers to build their own custom AI agents. Semantic Kernel integrates LLMs like OpenAI, Azure OpenAI, Hugging Face with programming languages like C#, Python, or Java. So it's extremely helpful because we can easily integrate our applications written in, let's say, .NET C#. We can integrate those applications with large language models, which are provided through Azure OpenAI, for instance. And this is what we are going to see in this specific video. So let's talk a little bit more about Semantic Kernel. Obviously, this video is not purely about Semantic Kernel structure and details. However, before moving forward, I want us to understand some of those concepts to make it easier to understand what's going on in the source code. So when it comes to Semantic Kernel, it's It's SDK, as I mentioned before, that we can use to integrate with LLMs in the Azure cloud. We can also integrate Semantic Kernel SDK with our existing application. And also, it uses different concepts like plugins, hooks, and filters. So let's talk about key components in Semantic Kernel. So there is AI orchestration layer, so the core of Semantic Kernel stack, which allows the seamless integration of AI models and plugins. Okay, this is very important, so we can easily integrate with those LLMs in the Azure cloud, for instance. Connectors enable developers to integrate LLMs into their existing applications. These connections serve as bridge between the application code and AI models, like those provided by OpenAI service. Okay, so this is very important. So we have this AI orchestration layer along with connectors to make sure that we can easily exchange information between our application and LLM in the Azure cloud. We also have plugins here, and this concept of plugin consists of prompts that you want the AI model to respond to and functions that can complete specialized tasks. So developers can use built-in plugins or create their own. So for example, there can be a plugin to retrieve documents from Azure AI service. And this will be presented in this video. So in this video, I will show you the AI agent with my custom plugin that I use to connect to Azure AI service to retrieve the data that then I will send to LLM in the Azure cloud implemented with Azure OpenAI to get the response for the user. And there are filters. Enhance security by providing control and visibility over how and when functions plugins run. So for example, filters are leveraged to validate whether a user is authorized to access specific data set. So in this specific video, we will also see how to implement authorization filter, to be more precise, to filter out the data before it's exposed or returned to the end user who connected to AI agent. Okay, perfect. So now, when it comes to identity management, I want to talk about authentication and authorization with Auth0 and OpenFGA for AI agents. So in this specific solution, as you saw, we need to implement user authentication, so to confirm who the user is, but also we have to implement proper authorization mechanism to make sure that users will only gain access to documents or to the data sources they are authorized to. So for this, I'm using OpenFGA. So basically, there should be a proper authentication and authorization in place. So that's why I decided to use Auth0, which is flexible and comprehensive identity access management provider that offers authentication and authorization services. And on the other side, for authorization, I will use OpenFGA and to be more specific, Okta FGA, which is the SaaS solution for implementing granular authorization. So OpenFGA is an open source project designed to handle fine-grained authorization at scale. It provides a flexible, scalable, and high-performance authorization system for modern applications. Okay, so to implement authentication, I'm using Auth0 here, and to implement granular authorization, I'm using OpenFGA with Okta FGA product. This is the solution architecture we are going to talk about in this video. So as you can see, on the right side, I have authorization engine, which is OpenFGA. There is identity provider, which is Auth0. And here I have my Blazor application with Semantic Kernel SDK integrated, okay? And now, as you can see, using Semantic Kernel, I will be able to search for documents in the Azure AI search. So as you can see here, those documents are indexed from Azure Blob Storage. Those are PDF files. And also I'm using OCR service provided by Cognitive Services to scan the PDF content and index it in the Azure AI search. And then, once documents are retrieved, we will send queries to the model that is provided using Azure OpenAI in the Azure cloud. Okay, so in this specific scenario, we are going to talk about Blazor application, web application, which enables users to send queries and to ask about different kinds of documents leveraging LLM in the Azure OpenAI, provided by Azure OpenAI, okay? And we will see how to implement user authentication using Auth0, and also how to implement authorization checks for documents before this information is returned to the end user. Perfect. So now it's time for practical overview. So let's jump into the practical demo to show you how to implement this authorization and authentication for our sample AI agent. So let's start. So here is my Blazor application integrated with Auth0, OpenFGA, and also with my model in the Azure cloud using Semantic Kernel SDK. So now when I click Talk to Agent, we can see that there is information displayed. Before you can talk to agent, you have to authenticate first. So I will click Login button and I'm redirected to the authorization endpoint of Auth0. So to secure this AI application, I'm using Auth0 here. So I've already created an account, so I will use my test account. I have to provide the password, and once I'm successfully authenticated, there is this greeting, "Hello, Daniel Tester." And now when I switch to Talk to Agent tab, we can see that now I can send queries to my agent. So I will type "hello" and I will send it. And we can see the response, "Hello, Daniel Tester. How can I assist you today with document searches?" So as you can see, here is my user identity provided by Auth0. So now what I can do, I can type, could you please provide me with invoices where Contoso is mentioned, like this, and I will send it to the agent, to the model actually. And as we can see, there is agent response. "Hello, Daniel Tester. Here are the documents mentioning Contoso in invoices. Invoice 2 PDF file and invoice 1 PDF file. Please let me know if you need further assistance." So now I can access those files and I can look into their content. And obviously in the real world example, I could extract the content, I could display this content here in this application, but this is only the demo solution. However, the thing is that there are more documents than you think. Not only those 2 documents in my knowledge base, but also I have more documents uploaded to the Azure Blob storage. So now let's move to the Azure portal to see how different things are implemented there. Okay, so here is the Azure portal, and I have all the resources created for this solution. So there is Azure AI Search, which I used to index my data. So index those PDF documents that are stored on the Azure Blob storage in this scenario. I have Azure OpenAI service deployed, so I can deploy those LLMs, large language models like GPT. I have Azure Cognitive Services resource deployed here because I'm using OCR to scan the content of those PDF files that are hosted on the Azure Blob storage. And now actually let me open this Azure Blob storage. As you can see, there are 7 PDF files. But as you remember, AI agent returned only 2 documents when I ask about invoices where Contoso is mentioned. Why? Because I have proper authorization in place, and this is what I will explain right now. So how actually those files are correlated to users stored in Auth0. So each file, under the metadata, as you can see, each file has file ID key and the unique value. So each file that is uploaded to the Azure Blob storage has unique file ID. And we will use this file ID when we will define authorization model using OpenFGA. So I will show you actually how to correlate this file with the user. So each file here has this file ID, unique file ID. And now when I get back and I will open Azure AI Search here and indexes that I created, here is my index that I created. Under fields, you can see that I have this file ID field name. So it means that when I will create this index in the Azure AI search service, it will also include this file ID property of the document that is stored on the Azure Blob Storage. Okay, that's very important. So each file stored on the Azure Blob Storage has this unique file ID property under metadata. So obviously in this POC, I created those file IDs manually, but in the production solution, you can try to imagine the situation that, for instance, a user through the application is uploading the file to the Azure Blob Storage. So we generate file ID, unique file ID for the document for this specific blob. And then we use this file ID to correlate this document with the user that is created in the Auth0. And I will explain this in a minute in this video. So once I have this data here, okay, I can close it. What I can do, let me show you that. I can type here like provide me with documents from Contoso, like this. And I can click search button, okay? And as we can see, under data count, I have 7 documents returned. Why? Because I have 7 PDF files. So as you remember, from the AI application perspective, you have access to all data sources and to the whole index. So that's why you have to implement proper authorization to filter out this data to make sure that you will avoid data disclosure and basically an unauthorized user will be able to see one of those PDF files on the blob storage. So as you can see, here is the title ID, obviously the text vector, so the content actually of the file. But the thing is that each document also, when I scroll up a little bit, you will be able to see each document has file ID property included. So when I will retrieve this data from Azure AI Search Index using this retrieval augmented generation approach, I will also gain access to the file ID for each file. Perfect. So now, please remember that each file has its own unique ID. Now, important thing is that using Azure OpenAI, I was able to successfully deploy GPT-4 model and also text embedding ADA model, because obviously here underneath a vectorized database is used. So when sending this query to the Azure AI Search, I will have to create embeddings, and then those embeddings will be sent to the Azure AI Search service, and then it will provide me with the right response. Perfect. So as you can see under deployments, I can deploy all those models I mentioned before using Azure OpenAI. And now the thing is that, as you can see, I can integrate with those models from my AI application. And I will discuss it in the code in a minute. Now let's open Auth0 here. So Auth0 here is used to authenticate users actually and manage user identities. But also I'm using Auth0 to secure my AI agent application, this Blazor application I created. So as you can see under applications here, I have this smart agent web application. So this is actually my application that I registered in Auth0 tenant, and I will be able to use this application actually and parameters in my Blazor application to secure access to it and authenticate users. When I open user management under users, you can see that there is only one user, just for the demo purpose, Daniel Tester. Let me open this user. And we can see that here is the unique identifier of this user, okay? That's very important. I have this unique identifier here of this user, and I will use this identifier to create relationship between the file stored on the Azure Blob Storage and this specific user, or users, because each user in Auth0 has unique identifier. Perfect. So now here is my identifier in Auth0. So now let me open Okta fine-grained authorization. So actually, this is the SaaS solution provided by Okta, which you can use to implement granular authorization in your applications. So if you want to use OpenFGA authorization solution or engine, you can host it anywhere using containers. You don't have to use Okta FGA. However, you are responsible for underlying infrastructure and configuration of OpenFGA, which is open source. So that's why I decided for this demo to use Okta FGA, which is a SaaS solution where I can easily create authorization models, define those relations between objects, and then easily integrate with this authorization model in my application. So here in the Okta FGA, as you can see, I define a simple authorization model. So in my authorization model, I have actually two types of the objects in my system. I have user and I have doc or document. And now for document, I define those relations. So there is relation called can change owner, and only owner will be able to do it. Can view, viewer or owner has this permission. Can share, only owner will be able to share this document. Can write, only owner will be able to write to this document. And also, as you can see, there is owner, which is user actually, and viewer, which is also the user, which is defined here. So on the right side, we can see this preview of this authorization model, which is nice. So I have my Secure AI authorization model, Secure AI store created here. And in this store, I have my authorization model defined. Okay, so in this authorization model, I have two types, user, document, and I have those relations between documents and users. Okay, and owner and viewer, those are the users. And now viewer and owner can read documents, but to actually write documents, only owner can do it. Simple as that. And now when I switch to tuple management, I have those two tuples created, okay? So actually, a tuple represents a relationship between concrete user and concrete object in the system. So, as you remember, I mentioned that each document uploaded to Azure Blob Storage has its own unique file ID, file identifier, and each user in our application has unique identifier too, provided by Auth0. So, as you can see here, I can create this relationship between user and object. So here, as you can see, I created two tuples just to test it. So under the user, I have user with this unique identifier from Auth0, which is actually my identifier of the Daniel Tester user. This user is in the relation to document with this specific identifier. And as you remember, I mentioned that this is file ID that is contained in the metadata of the file stored on the Azure Blob Storage. And I'm saying that the relation is viewer. But also, as you can see here, for another document with this file ID, the same user is owner of this document. Okay? So now when you remember, when I showed you the demo, when I asked for the invoices where Contoso is mentioned, two documents were returned. Why? Because my user can view document with this identifier, and also I'm the owner of this document. So actually, I'm the owner of one document and I have a viewer access to another document that is stored on the Azure Blob Storage. And the thing is that this unique file identifier is also indexed by Azure AI Search Service. So then when retrieving the data from Azure AI Search Service, I can filter this data out and I can check different relations between files and users using Okta FGA, so fine-grained authorization. So now, as you can see, I have those two tuples created here. Obviously, I can create more. So when I will click Add Tuple, I have to provide the user, I have to select the object, provide the object identifier, and select relation here. So in the production scenario, you can try to imagine the situation that when you upload specific file, you can also grant permissions for different users. When you delete file, you have to delete this tuple here. So obviously in the production scenario, it's more complex. But for now, I just want to discuss this authorization aspect in our AI agent. Perfect. So to summarize, I have Azure Cloud resources created. I have Azure OpenAI used to deploy large language models like GPT and to deploy a model to make it possible to create embeddings from the user query. I have Azure Blob Storage where I store PDF files with invoices. I have Azure AI Search Service created, which is used to index all those documents from the Azure Blob Storage. Each file on the Azure Blob Storage has its own unique file ID, which is stored under the metadata. In Auth0, I have all the user accounts registered for this solution. Each user in Auth0 has its own unique identifier. And also, I'm using Okta FGA or fine-grained authorization to define those relations between files and users to implement this granular authorization in my AI solution. So now let's get back to Visual Studio so I can show you some of the implementation details. So here is the Visual Studio with my Blazor application created. And this Blazor application is integrated with the Semantic Kernel SDK provided by Microsoft. So under core project here, actually, I have all the components that I'm using to interact with LLM deployed in the Azure Cloud using OpenAI service. So as you can see here, in this project, I have Semantic Kernel NuGet package added, but also I have this OpenFGA SDK added. This is the SDK that I'm using to communicate with my authorization model that I deploy using Okta FGA solution. Okay, so let me close this and let me explain some implementation details. So here I have this intelligent agent communication interface. And obviously it implements this interface with only one method, send message async. So we will use this method to send messages to our LLM deployed using Azure OpenAI service. Here, in this class, I'm using the kernel that is provided by Semantic Kernel SDK from Microsoft. And also I have this interface called Authenticated User Profile Provider. And now, under send message, as you can see, here is the message that will be sent by the user. But first, what I want to do, I want to get authenticated user profile. So I'm using authenticated user profile provider, get profile method. Let's go to the implementation here, okay? So as we can see, with this specific class here, what I'm able to do, I'm using access token provider here to get an access token that was returned from the Auth0. Okay, so here I have my access token here. And in the access token, I want to check the subject claim, so my unique identifier of the user in Auth0. But also what I want to check is first name and last name for the user. Okay, and then I'm returning this authenticated user profile object with ID of the user, unique ID from Auth0, email of the user, first name and last name. So this information is actually retrieved from Auth0 once the user is successfully authenticated. And now, important fact is that from the Auth0 perspective, I mentioned that I have my Blazor web application registered. However, I also have web API registered. So let's look at this now. So here is Auth0 management dashboard. And as you can see under APIs, I have this Smart Agent API registered. So in this specific scenario, under permissions, I have this only one permission, access Smart Agent. Access Smart Agent on behalf of yourself. I want to have this because when user will be authenticating in the Blazor application, I want to display this information like, hey, this Blazor application will be able to communicate or access Smart Agent on your behalf. Okay? And after user grants the permissions, or consent to be more precise, we will obtain two tokens. ID token, which will be used by Blazor application to confirm who the user is, and access token to make sure that Blazor application can communicate with AI agent API in the context of authenticated user. So that's why we need this access token here. And last thing is that in the access token, as you remember, I want to include information about the first name and last name of the user. So that's why under actions and triggers, we can see that under post login here, I have this add additional user attributes to access token, okay? So let me open this action really quickly. And you can see that here in the access token, I want to return additional claims. I want to return user email, I want to return user first name, and I want to return user last name. So in the access token return from Auth0, I will have those claims. So I will not only have unique user identifier assigned by Auth0, but also additionally, I will have email, first name, and last name. Perfect. So now let's get back to Visual Studio to discuss the code. So to summarize, once user is authenticated, we obtain access token and we can construct this object, authenticated user profile. So let's get back to intelligent agent communication interface. So here, once we have the user profile, and it's not null, we are creating the prompt that will be sent to this LLM deployed using Azure OpenAI. So as you can see, here is the system message. You are a document library assistant who helps users to search documents based on a document name. The user will provide the name of the document or some phrase which is included in the document in the user ask. Recognize the category name and perform a search. If user is authenticated and contacting you for the first time, greet the user with his first name and last name. And as you can see here, I'm providing first name and last name from the user profile retrieved using authenticated user profile provider from the access token. And here is the user ask. And here we are providing the message sent by the user. So here we are creating this prompt. And now, as we can see here, under OpenAI prompt execution settings, under user, we can provide unique identifier representing our end user, which can help OpenAI to monitor and detect abuse. So that's why here I'm providing the unique identifier retrieved from the access token assigned by Auth0 for this specific user here. And now below, I'm also using kernel arguments provided by Semantic Kernel SDK to remove authenticated user profile and add it to the data, which is actually the dictionary in the kernel. So here I'm providing this user profile to the kernel data. Okay, and this is the recommended and safe approach to provide any PII data about the users and pass it in the semantic kernel. So that's why I have this kernel.data.add authenticated user profile, and here I'm adding this authenticated user profile object. Once it's done, I'm invoking prompt with the prompt we created before with the user message, and I'm passing kernel arguments. Okay, so now I'm calling actually this orchestrator provided by Semantic Kernel SDK to proceed with this prompt. However, as you remember, I mentioned that here we are using Retrieval augmented generation. So before we contact our LLM in the Azure OpenAI, we want to retrieve some data using Azure AI Search. So we want to get information from those PDF files that we store in the Azure Blob storage. So here, under plugins, as you can see, I have this search document plugin. As you remember, I mentioned that actually plugin in the semantic kernel can be used to extend actually the functionality of our AI agent to, for instance, grab additional data and to pass this data in the request to our LLM in the Azure OpenAI service. So here I have this Azure AI document search plugin class, as you can see. And I have two components here used. So text embedding generation service, which I will explain in a minute, and index client. Okay? So now, as you can see, here is my kernel plugin definition. This is the official definition of the plugin in Semantic Kernel. I have this plugin called Perform Document Search, as you can see. And now if I get back to this class, I have also description. Search for a document similar to a given query. Okay? And description query from the user. And here I'm providing the query that is sent by the user actually. And what's happening next? So first of all, I have to create embeddings from the query sent by the user because I cannot send pure text to the Azure AI search. I have to create those embeddings because I have this vector database created in Azure AI search service. So here, text embedding generation service is using this ADA model, this embedding generation model that I deployed using Azure OpenAI. So I'm creating this embedding here, okay, to query the vector database. Next, what I'm doing here, I'm getting the search client with this index ID. So as you remember, I showed you that in Azure AI Search, I created index. I have this specific ID of my index here. So the index name here. So I'm creating the search client. And then what I'm doing here, I'm creating the vector query with this embedding that was generated using text embedding generation service. I'm adding those fields like text vector. And then what I'm doing here, I'm searching for the phrases that user ask in the query. And I'm using a search client, search async, and here I'm providing search options here. And obviously, here is the vector query I created from this embedding generated before. So to summarize, I'm querying Azure AI Search Service to look into those files, PDF files, to the content and provide me with the information whether there is some invoice, for instance, issued by Contoso. And what's happening in the end, obviously, we have the result. Obviously, we will get information back. If there is some document found, I will get it in the response, actually, here. So in the search results. So here, what we have to do, we have to go through each result and construct user document. So user document is this simple class with the file name property and file ID property. File ID is obviously the unique identifier of the file that I showed you under the metadata of the file. And now this plugin will return all found documents. What is important to mention here, those will be all the documents, not only those to which user should have access to, but also all documents that user should not access actually. So what we need here, actually, we have to filter out those documents and we have to implement granular authorization. So now, once this search plugin is called, before we will actually send this data to our LLM in the Azure cloud, and we will return any response to the user, we have to filter out this data. So let me close some of those files here, and let me open filters folder. And here, as you remember, at the beginning of this video, I mentioned that Semantic Kernel provides those filters that we can use to actually filter what we are sending to those LLMs. So I created this authorization filter here, which is using I authorize documents retriever. So let me first discuss this implementation here. As you can see, in this class, I have FGA file authorization service interface, and I'm using this file authorization service to query FGA, Okta FGA to be more precise. So what's going on here? I have this method called getDocuments with authorized access async. Here I'm providing the result of the function, so actually the result from my plugin. So in this specific case, those will be the documents. And also I'm providing authenticated user profile. As you remember, I have it, I constructed it from the access token, so I have this information about the user. So now, as you can see, I'm getting all the documents retrieved from Azure AI Search Service. And here, if obviously there are more than 0 documents, I need to check whether a user is authorized to access those documents. So as you remember, I mentioned that user is authorized to access the document if user is an owner of the document and if user is viewer of the document or has viewer relation to the specific document. So that's why here, as you can see, I'm using FGA file authorization service, retrieve authorized documents. I'm passing those documents retrieved by my plugin. I'm passing the unique user ID from Auth0, and I'm passing information about the relation. So in this case, I'm checking whether user is an owner of any of those found documents returned by Azure AI Search. So I get documents owned by the user, and also I get documents shared with user as viewer. Okay, so here I'm asking Okta FGA, hey, check if those documents can be viewed by the user with this unique identifier from Auth0 and whether the user has viewer relation to those documents. And now, once I have documents owned by the users and documents shared with the user as viewer, I can merge those documents and return found documents. So only those documents that user can see and those documents that user is owner of. It's very important. So you see, I'm not returning all the documents. I have this granular authorization in place. So now what will happen here, when I scroll down here, there is this method provided by this filter on function invocation async. And here, what I'm doing, I'm checking if the plugin that was called is the search, is actually perform document search plugin. You see? So here, if this is the perform document search plugin, if this plugin is used in the pipeline in Semantic Kernel, I call perform authorization check async on the context. And what will happen here under perform authorization check async method, here I'm getting information whether a user is authenticated because I'm using kernel data, as you remember, and here I'm trying to obtain authenticated user profile from the kernel data. And now, if is authenticated user profile present is false or user profile is null, I respond here with such message. Respond to user, please authenticate first so I can search for documents on your behalf. However, if we have this authenticated user profile, here we are getting this, and we are using authorized document retriever, which is leveraging OpenFGA SDK to get documents to which user should have access to. And now, obviously, if there are no documents, if user is not authorized to see any documents, we are prompting this information, respond to user. Unfortunately, I did not find any documents related to your query. However, if there are documents found, return those documents. Okay? So now the thing is that using Okta FGA, we can implement this granular authorization. We can check user relation with specific objects like documents. We can filter out those documents. And now, in the end, if we get back to intelligent agent communication interface, we will get information about the documents that user is actually authorized to access. And that's very important. So as you can see, we have this structure. So we don't want to respond with all the documents. We actually want to first retrieve those documents from Azure AI Search Service. We want to check the relation between those documents and the user using Okta FGA, a fine-grained authorization. And then we want to respond to the user with the information generated by LLM in the Azure cloud, deployed using OpenAI, to respond to the user with only the proper documents. Okay? So now, if we try to debug this solution, we can see what's happening step by step. But before I will do it, let me open one more thing here. So under Pages, I have this Agent Console page. And this is my Blazor application, obviously. And here, as you can see, I'm using intelligent agent here and send message async method. Okay, so here I'm sending a user prompt to the agent. So now let's try to debug it to see step by step what's happening here underneath and how this granular authorization is implemented. So now let's see step by step what's happening in the code. So I have to authenticate first. So I click login button. I'm redirected to the login page provided by Auth0. I'm providing my credentials. And once I'm authenticated successfully, I'm redirected back to the application. Now I click talk to agent. And now I will send this query. So can you provide me with documents from Contoso, like this, and I click send button. So as we can see here in the Blazor application, authentication state provider is used, and we have to check whether user is authenticated. And we can see that is authenticated is set to true. So if user is authenticated, we can proceed with calling send message async on intelligent agent instance. And the thing is that we have information about the user identity because Auth0 return ID token. And as you remember, I also registered this secure AI agent API in Auth0. So actually underneath, I obtain two tokens, ID token for the Blazor application to confirm who the user is, and access token to call my API that I'm using along with the Semantic Kernel SDK. Perfect. So now I call intelligent agent send message async method. So I click continue. And here, as you can see, I'm using authenticated user profile provider, and I have information about the user profile. Important thing is that I have unique identifier of the user provided by Auth0. So this is my unique identifier of the user in Auth0. So now what I can do, I can create this prompt that will be sent to the LLM deployed using Azure OpenAI service. Important thing is that before I will use invoke prompt async on kernel, I'm adding information about the authenticated user profile to the kernel data dictionary. Okay, so when I will call invoke prompt async, under the data, I have this authenticated user profile, and here is the information about the authenticated user. Perfect. So now I call invoke prompt async, and as we can see, my perform document search plugin is executed. Okay. Under the query, I can see documents from Contoso. So I will try to find anything related to Contoso in those PDF files that I uploaded to the Azure Blob storage, okay? And important thing is that once the query is executed, under found documents, as you can see, I have all 7 documents from the Azure Blob storage. Not those 2 initially you saw when I presented this demo for the first time. So I have access to all 7 documents here. All 7 documents are returned by Azure AI Search Service. However, the thing is that I should not have access to all those documents. I should have access only to 2 of those documents where I have this relation set to viewer and the owner. So actually, I should have access only to 2 files instead of 7. So let's see what will happen next. So I will click continue button. So we can see that perform document search was actually executed. So this plugin was executed. So in my authorization filter, if I see that perform document search plugin was executed, I call perform authorization check async. Okay. So here I will click continue. Okay. And I'm getting information about the authenticated user. Okay. If user is not authenticated, obviously we'll respond, please authenticate first so I can search for documents on your behalf. However, if there is an authenticated user profile included, as we saw before, we will actually use authorized documents retriever instance with get documents with authorized access async method. So what's happening here, let me show you that. Let me click continue. Here, I'm providing the context result, and under context result, I have information about those documents from actually Azure AI search service. So 7 documents, as you can see. And I'm providing authenticated user profile here, which is my user account registered in Auth0. So now, let me go to implementation here. And as you can see, I will click continue button. Here, I'm calling Okta FGA to check whether I have owner relation to some of those documents or viewer relation to some of those documents. Okay. So once I execute those queries against Okta fine-grained authorization, you can see that I'm the owner only of one of those documents, so invoice2 PDF file. And when it comes to documents which I can access, which I can view, there is also one document. And let's see, it's invoice1. So in total, I should have access only to 2 PDF files from the Azure Blob Storage instead of 7 initially returned by Azure AI Search Service. So now, under found documents, I only get those 2 documents. Okay? So now under authorization filter, here, as you can see, found documents count is equals 2 actually. So I'm returning only here under the function result, I'm returning found documents, only those 2 documents. Okay. And now if I go to intelligent agent communication interface, and I will click continue, I have this answer from my LLM. So let me open this. Hi, Daniel Tester. Welcome to the document search service. I've found a couple of documents from Contoso for you. Invoice 2 and invoice 1. And we can see ID of those files. And here is the additional information. Let me know if you need further assistance. Okay. So as you can see, this LLM returned only 2 documents because I use this authorization filter and I use Okta fine-grained authorization to check whether a user is owner of the document or whether a user can access document because of the fact that user has this viewer relation when it comes to specific document. So now when I click continue button, you can see that I'm displaying this message from my AI agent here, and only 2 documents are mentioned here. That's it for this video. I hope you found it interesting and helpful. If you want to learn more about secure cloud development and identity topics, I strongly encourage you to visit my techmindfactory.com blog. I also encourage you to subscribe to my YouTube channel, where I have dedicated playlist around identity called IdentiSphere Explorer. Thank you so much for watching and see you in the next video.